Hi there. In this lesson, we're going to look at something called standard deviation. And the title here says standard deviation, a better measure of spread. You might be thinking, well, why? What's a better measure of spread? What is a measure of spread? If you're talking about data values, it's how spread out the information is. And if you look at things like the range, that will tell you how spread out information is. The highest take away the lowest, but it ignores everything in the middle. It just concentrates on the end values. And if you've watched the earlier lessons of interquartile range and semi-interquartile range, they ignore the end values and only take into account the kind of middle values. So the standard deviation takes into account everything, and that's why it's classed as a better measure of how spread everything out is. Right, what is it? So here we have, so for a set of values, the standard deviation is a measure of how far away, on average, each value is from the mean. So if we look at petrol prices, and particularly in Kilmarnock, so I live in Kilmarnock, or just outside me teaching Kilmarnock, but the average petrol price is £1.04 at the moment. Coronavirus is about, the petrol prices dropped and so on. So it's £1.04 per litre. Now, each individual place is different to that. So Jet is £1.10, Tesco £1.2, Morrison's 99 pence, and Shell £1.6. There's other ones as well. The average petrol price here is £1.04. That's 2 above the average, that's 5 below the average, that's 6 above the average, and that's 2 below the average. So the standard deviation will tell you roughly, if you go to Kilmarnock, how far away from the average price is most petrol stations going to be. That's what it is. How far away on average are most petrol stations within 2 pence of the average, within 3 pence of the average, or so on. Now, this usually works with what's called a normal distribution. Now, a normal distribution is this kind of bell-shaped curve. It happens quite a lot in nature, and probably relating to more exam scores than what you guys will imagine. So in exam scores, if you take this middle line as the average, most people get round about the average score, and then it tends to drop off with the top marks kind of lower and the lowest marks lower. But most people congregate around this middling area, and this happens with people's weight, height, blood pressure and things. Usually most people are about the average, and you get to the kind of far ends, it kind of tails off. So this is what's called a normal distribution, and generally standard deviation works with a normal distribution of things. Now, what does this tell us? Well, basically from this kind of shape from data studies, roughly 2/3 of the data usually falls within one standard deviation of the mean. 95% fall within 2 standard deviations, and nearly everybody falls within 3 standard deviations of the mean. Now, to better understand this, we're probably best to do an example. So let's look at an example and see what we're actually talking about here. So I've got an example here. It says 6 pea pods were opened and the number of peas in each were counted. One had 6, one had 7, 9, 9, 10, and one had 13 in it. This one had lots in it. So the question is, calculate the mean and then calculate the standard deviation. Okay, right, so the mean is basically add them all up and divide how many there are. I'm going to look briefly at a new notation. So that's basically it, isn't it? Add them all up and divide how many there are. But this is the notation for the mean. It's called x bar, and quite often you see it. You'll see it in the formula for standard deviation, which we'll talk about in a second. But when we talk about the mean, it's this idea of x bar. So x bar, you've got to add all these numbers up, 6, 7, 9, 9, 10, and 13, and divide by how many there are. So I'm going to do that here. And if you add them all up and divide by 6, you're going to get 9. Make sure if you're doing the calculator, you hit equals first, divide by 6, you get 9. Right, that's the first bit. So you probably knew how to do that. Let's look at the second bit, the standard deviation. So we've got to find out how far, on average, each of the 6 values is away from the mean. Now, the way to do this is we usually create a table. Now, all the data values in the table are here, 6, 7, 9, 9, 10, and 13, just from up here, 6, 7, 9, 9, 10, and 13. And this is basically saying, well, if x bar is the mean, how far is each one of these away from the mean? So you've got to do, well, 6 is x, take away the mean. Now, the mean was 9, wasn't it? Okay, so that would be 6 take away 9. Now, you just write the answer in. 6 take away 9 is -3. Then you'll do 7 take away 9, -2. 9 take away 9, that's straight on the mean, isn't it? So that'd be 0. That's the mean as well, so it'd be 0. 10 take away 9, that's above, so it's 1 above. And 13 take away 9 is 4. Now, to get the average that they're away from the mean, you would add them all up and divide by 6. But watch what happens when you add them all up. 4, 5, 0, 0, -2, negative. You're going to get 0. So this was a problem for statisticians. So what they did was, they did a wee trick. They squared everything, like this. So they squared the -3 to get 9, squared the -2 to get 4, and so on. And then they added up and divided by 6. But you might go, well, wait a minute, you can't just square stuff. So they're going to add everything up and divide by 6. But what they did after that was they square rooted. So they square rooted to cancel out the squaring. Now, this bit here at the top, this is the formula for standard deviation. This bit here at the top, this is sigma, and it means add all these bits up. So that's you adding them all up, and that's you dividing by how many there are. So see this answer here. See if you add all these things up here, you're going to get sigma x minus x bar squared, if you like, which is the top line of the formula. So the top line of the formula is basically going to be 16 plus 1 plus 4 plus 9. So that's coming to what, 30. And you're going to divide by 6, and you're going to square root it. However, there's another wee kind of crux, if you like. When statisticians did this and they compared it to the distribution in the normal graph, if you like, we talked about before, the normal distribution, they found that it was more accurate when you took one away from the number of numbers. So the top line is going to be 30, which we just did, and the bottom line is going to be, how many were there? There was 6, but take away 1, which is 5. So you do 30 divided by 5, which is 6, and you square out your answer, and you get 2.45. So this is what the standard deviation is, 2.45. Now I'm going to do another example in a second to show you how it's done again. But what does this mean? So assuming the normal distribution, the average number of p's in the p-pod was 9, and we've got the standard deviation of 2.45. Now, when we looked earlier at this idea here, we said 2/3 of the data usually falls within one standard deviation of the mean. So we can pretty much say, if we just go back to that 2/3 go a bit lower than the mean and a bit higher than the mean. So 2/3 of the p-pods have got 6.55 and 11.45 p's in them. That's 9 take away 2.45 and 9 add 2.45. So it's a good estimation, isn't it? You obviously don't need to do it with people, you can do it with athletes or anything you like. You can work out standard deviation and work out if people are round about the average, away from the average, 2/3 of the data is roughly what, who's falling within this category, and you can do a lot of analysis with it. Right, let's look. So the formula is a wee bit, so you add everything up, you square it, square root it, and divide by how many there are. Things take away 1. We'll have a look at that idea again, okay? So Claire collects frogs and measures their weight. Calculate the standard deviation. Right, let's get the mean first, and that's called x bar, isn't it? So you add everything up and divide by how many there are. So it's 20, blah, 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 divide by 5, and that's going to give you 31. Right, you've got to draw your table out. Now that's got all the values that are there. So that's what, 28, 31, 40, 27, and 29. Now, the next bit in the table is x minus x bar, and then you square it. So I'll go through this column first. So this is x, take away the mean. You're finding out how far they are away from the mean. So we do 28, take away 31, minus 3. 31, take away 31, 0. 40, take away 31, 9. 27, take away 31, negative 4. 29, take away 31, minus 2. Now we can't add all these up and divide because they will cancel each other out. So we square them all, then add everything up. So if you add all these bits up here, you're going to get the top line of the formula, which is 110. See how that bit? That's the sum of all of those. That's what that means. And that bit's in the formula. There, it's there. It's 110. Now, because we squared everything, we've got to cancel it out by square rooting it. And there's the adjustment that statisticians made. How many numbers take away 1? Well, there's 1, 2, 3, 4, 5 numbers take away 1. So the top line's 110. The bottom line's 5 numbers take away 1, which is 4. Divide it, and then square root it to finish. So the standard deviation is 5.24 for this. Now, what does this mean to do with the frogs? Well, the average was 31. The standard deviation is 5.24. So 2/3 of the frogs have a weight between that lower than 31 and that higher than 31. So 2/3 of the frogs have a weight between 25.76 and 36.24.